Hello all, this is a video on instruction cycle for the computer organization subject. Now let us start off. So there are two main parts in the instruction cycle. The first one being the CPU, a program counter, an accumulator, an instruction register, an MDR and an MAR. The second part is the memory, which consists of the main memory, also known as the RAM. As you looked at them individually, it is time for you to look at them as a whole. So, if all the pieces were to be put together, the whole big picture would look something like. You will be able to see the picture on the screen in a moment. So that is how the entire big picture looks like. Afraid that was the simple part. That was just a simple representation of the actual instruction cycle. Of the instruction cycle that you just saw was easily understandable. However, the actual diagram is a bit more complex and needs pretty much more understanding. So the actual hard part looks something like this. It's pretty complicated, isn't it? However, there's yet more to come. So now we'll start talking about the different parts of the instruction cycle. Part is the registers, which consists of the program counter, the MDR, the MAR, the instruction register, and the accumulator. Second part is the RAM or the random access memory, which contains instructions and addresses. The third part consists of two components, namely the CU, the control unit, and the ALU, that is the arithmetical logic unit. And the fourth one is bus, namely control bus, data bus, and address bus. So the execution of the instruction cycle begins with loading an address into the memory. This is what will happen now. The address AE00 gets loaded into the PC, that is the program counter, which is later passed to the MAR, that is the memory address register. Then the assembly language instructions for loading registers with an 8-bit integer pattern is executed. The location AE00 is accessed by the address bus. Please take a moment to look at the picture and analyze it. The diagram has very important points. Later, the execution of the instruction cycle continues, and this is what happens. The commands in the respective addresses are performed. AE00, then AE01, AE02, and so on. Then, logical operations such as addition, subtraction, etc. are performed in the arithmetical logic unit. The accumulator, as the name suggests, stores values for further operations. In the end, the control unit increments the value of the program counter, causing the next command to be executed. This loop goes on until all the commands in the memory are executed. This was a presentation by me, Anirudh Kumar. Thank you everyone.